All right, hi Praful, Monjoy, and Lee. Thought I'd share with you some of the old ideas for the arraying we used to put to work in the old days, both 1D and 2D. So let's see if this works. So let's start by considering the whole array. And now assuming there are a few cores here. So let's be nice first and then twist it a little bit. For instance, you could imagine the third row is missing something here. Move to the third, and the fourth row is out of line. For example, something here, and something here. So in the old days, we would start by segmenting, just like you did today, Praful, and Monjoy, you did with your boxing. So let's imagine these are recognized. So these will be circles of a given size. You see that at the end, so here I'm missing something. I'll try to convince you that there are a number of interactive steps that make this job efficient at scale. But let's start with the basics. So and the jobs could include, for instance, changing the diameter of the circle, clicking on the circle, extending it, that sort of thing. All interactive, I imagine, with SVGs. But let's go back to the old ideas first in case some value is still there. So you recognize the center of each circle, and then starting on the upper left-hand corner, you'd look for the two closest neighbors. So you have this one and this one. The third neighbor is further than the others, so it wouldn't be connected. So then you move to the next one and you do the same. The two closest are this one and this one, not this one and this one. This would be longer. So it would stay there. Same thing here, 1, 2. Same thing here, 1, 2. Same thing down. And here, actually, there is a hole, so the next closest will be far ahead. And same thing here, this guy and this one. And now here, interesting thing starts. Say, well, there's nothing here, so this is the closest, and we are missing something. So this will be messed up. Like, say, it could be from here to here for sure, but maybe from here to here. And at this point, you say, well, of course, your algorithm would continue. There will be a mess here. So let's go choose a different color. This one, and it's let's put something here manually. And the moment you finish, the algorithm redoes its thing. And when it does its thing, now it's okay. It finds that it's this one. And here, same thing. So the closest neighbors are not in diagonals, are in this way. Now here, the same problem, you could say, well, let's imagine that this is really messed up. Remember, this should be furthest from this one than either of these two. But let's imagine this is actually closer than, say, this one. Okay, so it would connect here. Now we have a problem because we have a core with 3 connections. And this one is not connected to anything. It may end up here. See? Now it's a mess. It's 4. So when you get to this point, you know that there's some problem with your algorithm, and you need to manually cut connections. So you cut this one. This is where the interaction makes a huge difference, because the moment you cut and with this recognized, you'd force it here. So now it's good. So see, we're now 4, and we can of course finish this one. It's no longer a problem. So this is how we would do it, by having simple rules that would just scan the segmented objects, and after maybe you give the opportunity for the user to move the circles a little bit around. You know, there will be one or another where the segmentation didn't do well, but it's really in the ability to cut connections and let the algorithm then reconnect things that the trick is. So there is another possibility, which I think is the one that Halo was using, which is to recognize some sort of rigid matrix. So like this. And then you have, I guess this will go straight, and then you have the option to move the node. So you can pick any node. This includes on the edges. And you can push them. So you can push this node this way, for example. And when you push it to this way, the distance between the nodes is now like a coil. Now this requires a bit of, it's not complicated programming, but it's programming that has to be well conceived. Because when you push one node, the matrix is allowed to bend. So maybe this guy moves a little bit this way, and you need something that pushes it back. And that something would be using an objective criteria, such as the degree of segmentation, of successful segmentation. So when you move things such that the segmentation is now moving away from the actual object, the blue wiggly thing here, then the segmentation will be hurt by this movement. So there will be resistance back. So this second approach is more mechanical in nature. The first one is a quadricule being recognized and recorded, whereas this first one is moving things around until you recognize that, for instance, this line now does this, and here does this. So I'm not so sure if this other approach would be useful. In the old days, it was too intensive computationally to be practical. Clearly, it's not a problem these days. In any case, hope either of these ideas are interesting to you. Bye now.